Okay, welcome back, ladies and gentlemen. We are talking about functions, and last week, we had just learned about how to move things left, right, up, down, and then flip things left, right, or up, down. And hopefully by now you've got it figured out that the stuff on the inside is the which way, left, right, or up, down. It's the left, right stuff. And the stuff on the outside, which could be either here or here, is the up, down stuff, right? Okay. Now, if you're going to do these things in the right order, which you want to do if you want to get the problem right, you always want to do the multiplication stuff first. Okay, so of this whole thing, that's the only thing that's a multiplication. It's multiplied by what? By -1. All right, so that makes the thing flip. I want to do some exploring with the calculator on this. I want you to type this one in right here on your calculator as you see it. And we're going to kind of investigate this through our calculator. So hit pause while you get that ready. Okay, so there we have it. Do you see that this used to be a normal parabola? Until some things happen, right? How about that -1 in front of it? What did that do? They flipped it up, down. And then the -4, do you see that it's been moved to the right? 4. All right, and then that +7, what does that mean? It's moved up 7. All right. Now, this is not actually the best view of the graph. Zoom 6 is a really common one. It's a standard zoom. But there is a better one. And the reason I say that is, do you see that the little tick marks on the bottom part of the graph, the x-axis, are different than the tick marks going up the side? They're different widths. Did you ever notice that before? If you go to zoom, which do you think? Zoom square, 5. That will make the tick marks equal on the, equal in size. All right, so now but it's still hard to get perspective on what the original was. You know what I mean? So the original graph, like what did the parent look like if it had a normals, like a normal zoom? So I go to y equals. Let's graph the parent in there with it. What's the parent one? X squared. X squared. And then I hit graph. And now I can see the original one in there, and I can see that this one has been flipped and moved over and up. That make sense? Okay. Now, let's look at some other zoom options we have. We got zoom in or zoom out. All right, if I want to zoom in, did you know that, I know most of you guys, you go down to zoom in. Go ahead and try this one. Hit zoom in and then hit enter. And a lot of people to start with are like wondering, why didn't it zoom? It's because now you're just back to the graph and now you actually have a choice of something. Your choice is, where do you want to zoom? Most people just hit enter again right away. And do you know where it's going to zoom in then? Do you see the little blinky thing right on the origin? There's a little blinky thing right on the origin. It's blinking on and off. That's where do you want to zoom? So if I want my zoom centered like over here, like in the midst of all this stuff, then if I go like this, it'll zoom into that area. Okay? I bet you a lot of you didn't know that about your zoom. Hit enter. And now I zoomed into that area. Now I maybe got in too deep, so maybe I should zoom out. So I'm going to hit zoom out. And let's say as I'm zooming out, I want to zoom out in a certain area. Like, I'd really like it to more go a little bit to the left or something. So then I go over to the left here and maybe down a little bit or whatever. And then I'm going to zoom out from there. It's like they just lift the camera back straight from there. And now you can see your graphs again. Okay. And I think I've showed you the Z-box already, haven't I? Maybe not. Hit zoom. And do you see that #1 zoom that they have on the list? Zoom box. There's a reason they put it at #1 versus some of them are like zoom #8 because nobody ever uses zoom #8. Do you think Z-box might be kind of important? So let's learn how to use the Z-box. If you want to see Z-graph, you should use Z-box. I hit enter. And now this one, it implies I'm going to put a box around an area, right? Doesn't that make sense? So do you see the same blinky little dot? We need to arrow over, and that's going to become the left edge of our little box. The upper left would be ideal. And let's say we want to start our box there. Okay, so get your little blinky thing up where mine is in the quadrant number 2, and somewhere in the neighborhood of 4.5 to the left and up 7.5, something like that. Okay, now I hit enter. That locks in as the corner of the box. Then I'm going to arrow to the right. And I'm making the top edge of the box, and then I'm going to arrow down. Once I kind of got a box around the area that I want to see. And that's the main area that I want to see, so I'm going to zoom in there. So I hit enter, and it turns it into on a graph of exactly what you asked it for, which is that kind of area. Yes, the box helps you see the graph. It reminds me a little bit of the those movies where you're watching like the crime-solving people, and they're looking at the videotape, and they're like, let's zoom in on that face right there. And then they like, you know, grab the little camera thingy and zoom in on that one little face and make it blow up there. Not blow up, not explode, but I mean like make it bigger. Yeah. Anyway, so this is the Z box. All right. And what if you get sick of all that and you're like, I can't even figure out where I am anymore on the graph? Where's the best way to get back to normal? Zoom 6. Zoom 6 is the normal zoom. All right, so I just want to talk over zooms with you a little bit. All right, so now what we've got here is a parabola that has been moved and flipped, but we haven't stretched it. Which number do you think I should change in that top equation to make it a stretch? Yes, sir. The negative one. And we should make it a? Sure. Let's change it to a -2. And I hit enter. Or graph, sorry. Now, if you're looking at the old one versus the new one, it's really hard to tell that the parent one compared to the new one, that the parent one has still been flipped. That was the negative talking. The 2 is the only difference. So it's really hard to compare these because one of them's been stretched and one of them hasn't. Do you see that the one on the right is a little bit narrower? It is. And it's been stretched. Imagine if there was a giant who grabbed you by your feet and by your shoulders and then pulled on you. Imagine that you would stretch, you'd get taller. Well, unless you broke into pieces. There was the old days, they'd put people on the rack. And there's actually precedent for people stretching themselves to get taller. It actually can work. It actually isn't like you can't get dramatically taller, and usually it only works for situations like this. Weightlifters who lift a lot of weight, like me, typically get a little shorter because they've been lifting these heavy weights and they've been putting a lot of pressure on what part of their body? Their spine, their back, and that makes them shorter. And they can relieve that and get taller again by stretching themselves out. And so sometimes it'll be pretty dramatic. Somebody has been weightlifting a long time. They've shrunk actually like an inch or 2 just from their spine compression. And then they get on they put these boots on and then hang upside down from the boots. And they do that for, very short periods of time to start with and then longer and longer. And eventually their spine stretches back out again and they can get their couple inches back of height just from the compression in their back. Yes? Yes, I've done it before actually, and at first it's almost a little painful, but then it seriously only takes 3 or 4 times, and you kind of get used to it, and then you can hang there for like 20 minutes. Doesn't bother you, and that's true. It's true. It doesn't like burst the capillaries in your brain or anything crazy. I mean, there actually is. You have to be careful with it if you're like an older person, or and I suppose if you had like a weak blood vessel in your head naturally, that could put a lot of pressure on it. But apparently, I don't have that. But that's okay. It's okay to record all. Whatever I'm saying in class, I'm not saying anything that I can't have recorded. Okay. Anyway, so what are we? We're trying to compare the original one, the parent one here, to the one that's been stretched double, but I'd really like to just take that top line and recreate it with the exact same thing except with a -1, so I can compare them side by side. You know what I mean? So let's go make the exact same graph except with a -1. Don't use a minus like I just did. I got to clear that now. Oopie. -1. 1 times parentheses. Do the whole exact thing with a negative 1. X minus 4 parentheses squared. Oops, not second. Squared. There we go. Plus 7. And then you'll be able to compare them really side by side and see that one of them has been stretched and the other one hasn't. The narrower one has been stretched. I know it's a kind of a weird thing, but when you grab a hold, if this was made of rubber, okay, and you grabbed a hold of them and you pulled on it, it would stretch the thing down. I mean, just if you imagine grabbing it here and here, and you grab a hold of it and you pull down, you get the one on the inside. If yours doesn't look like that, you typed in something wrong on your graph. All right. I would like you to try clearing these out completely now, and we're going to graph something totally different. So go to y equals, hit clear, arrow down, hit clear, and then go back up to the first one. Let's just do the square root graph. Square root's right above the x squared. Square root of x, hit graph. You see how with the zoom we've got right now that we're kind of wasting, like we're only seeing 1/4 of the graph is what we want. We don't need the bottom part. We don't need the left part. So this time I'm going to show you how to do this with the window. Think for a second. Do we need any negative x's or negative y's? So then go to the window button, and I want you to go to x min, and I want you to say 0 is the lowest minimum x I need, and the minimum y I need, 0. I don't need any negatives. And then hit graph. Seeing how I'm focused in now on the part I really wanted? So a window's another good way to make your calculator work for you. I'm going to try to focus this year on making sure you're really good at using your calculator, because you use it a lot next year. And if we get good at it this year, it'll help you this year and next year. It can be kind of like a calculator ninja. All right. So now, yes. If I go to y equals again, how do you think I could make this thing get twice as tall? A 2 in front of it. I hit enter, put a 2, sorry, insert, get a 2 in there, and see how now I got the twice as tall. Hit graph. Now it's hard to even remember what the old one looked like. So again, I would go down to the second y and put in the original one, square root of x. Square root of x and hit graph, and now I got both of them. I got the original one and the one that's twice as tall. Do you see what twice as tall means? You see how it's kind of like I grabbed it if it was made of rubber and I pulled it up, straight up, and it was attached right down here though. Like that's a spot where it stayed attached, and 0, 0 didn't change. All right, because when you do an upward stretch, you're taking how tall it was and making it twice as tall. How tall was it at 0, 0? 0. So when you double its height, it's still 0. Get that? That's why it sticks there at 0, because its height is 0. When you double 0, it's still 0. All right, so that makes it twice as tall. Any wild guesses on how I would change this 2 to make this thing half as tall? Well, you get a 0.5. So everybody do that. Point, you'll have to insert a 5, otherwise it'll copy over the top of your square root, which isn't the end of the world. But make it 0.5x, however you can do that most efficiently. Graph it. And here's my normal one is the one that goes a little higher now. And the really short one there, that's my one that's been stretched. Not stretched, shrunk vertically. All right. Do you remember how I was saying the stuff on the inside, you can't trust it? That seems to me like it should be moving to the left, but it really moves to the right. This is another one of those times. When we put something on the inside, it doesn't do what you'd expect. So go back to your calculator y equals screen. And this time, let's get rid of the stuff in front by hitting the delete key. Hit delete when you're over it. It'll just get rid of those things. And in the inside, we need to put parentheses in here. I know you're going to think that we don't need to, but trust me, there's a really important thing coming up that will remind you more about this parentheses. If I did that, would that make it wider or narrower? No, it moves the whole graph. Which way? To the right too. So how do I get the whole graph to move to the right too, but also get narrower or wider? All right, let's throw I'm going to make it even more dramatic. I'm going to times it by 5 in there. So I'm going to get my 5 right there. I'm going to insert a 5. All right. Now this should move the thing to the right too and make it not 5 times wider. Remember how I can't trust the stuff on the inside? It'll make it what? 5 times narrower. That's another good way to say it. Or 1/5 as wide, if you're trying to say it that way. All right, hit graph. It moved over, and it made it narrower. What does that really mean? It's like if the giant again, and instead of grabbing the people by their feet and by their head and stretching them out, you're grabbing them and you're squishing them down. Okay? It's like if I grabbed it right here. It won't let me draw over there. If I grabbed it right here and I pushed it back this way, you know how it would kind of bend up? Does that make sense to you? If I push it back this way, it's going to squish it down. I also moved it to the right a little bit. All right, these are easier to see on normal parabolas. So now I'm going to go back to this, and I'm going to change this to a parabola. How do I do that? Well, let's get rid of the -2. So we just hit delete on the -2. And I'm going to put a squared right there. Oh, wait, I don't want the square root. Nah, just clear the whole thing. I want this to be x squared, except inside that, I want an x in parentheses, and then squared. And why did I put the parentheses there? Because if I put something inside the parentheses, then that moves it left-right, or stretches it left-right. So I'm going to put in a 5 right there. In the next line, I'd like you to just have the normal x squared. So, and now my window's all goofy. Go zoom 6. Zoom 6. Normal parabola, you see the normal one and you see the really squished one? Does it make sense to you that we did something on the inside that should affect left-right? When we put a 5 in there, you'd think it'd be 5 times wider, but it's not, because it does the opposite of what you expect. It's 5 times narrower. Okay? All right. Now, how would I make this whole parabola not only get narrower, but let's say it moves to the right? Well, then I go inside of this, and how do I get this to move to the right? If you just go insert a -2 here, and then I hit graph, it does move it to the right. I don't know if you can see it's been shifted to the right. Let's move it even farther to the right. Let's move it like 4 to the right. So let's go back to the y equals, change this to a -4 right there, and hit graph. Should be a little more obvious now that the thing is moved to the right. Okay. We could get it back out to the normal width by getting rid of that 5 in there, but I just want to show you both at once. See, this is the tricky part. Look at the top there, 5x minus 4 squared. Here's what a lot of you guys did on your quiz. Now, the question is, which of those two is actually, oh, I got that extra weird little phantom squared going on. I get rid of that. There. Which of these two is the right answer for making it move to the right 4? The top one or the bottom one? Do you think the parentheses are important in there? Or do you think we should not have parentheses? I think they're both going to move to the right 4. Okay?
Oh, no, it's possible.
All right. Well, let's find out. On the top and the bottom, I obviously have different things. You agree that they're different if I put a parenthesis in there? I don't really need the parentheses at the front. That's not what I'm talking about. Let me get rid of those. I'm talking about the parentheses that's on the inside. Oh, I can see what. Uh-oh. I'm going to clear this. I'm going to delete that. Remove my parenthesis. I'm going to put double parentheses. Sorry about this. I'm realizing that one of my parentheses was off. Second. So I got to put parenthesis back in here. Second, insert a parenthesis there. And then I go to the end. Now I got to square the whole thing. Okay, and now I go squared. Okay, now I'm going to ask it again. Do you see how the top one and the bottom one are only different because there's a parentheses around the x minus 4? All right, this is a crucial difference. Some people are going to get this right on the test. Some people are going to get it wrong on the test. If I hit graph, are they in the exact same spot? Obviously, they're not. So only one of them moved to the right 4 places, didn't it? Well, let's try to figure out exactly where these spots are. I'm going to go to trace. 1 second, I'm just going to trace. And that brings up the little spider thingy. And I must see if I could find my little spider. Where is he? -8, 2000 something. Oh, great. Okay. I want to get... I'm having all kinds of technical difficulties today. Because it's riding this parabola, the parabola on the right, and it's going up, up, up on that parabola. And I don't know how to get it off of that and onto the other one. Okay, I'm just getting lost in the technology here. And I'm going to go back to this, and I'm going to tell you which one's right. Only one of these makes it move to the right 4. The other one makes it move to the right a different amount. Okay, the top one versus the bottom one. How many of you think the one on the top is the correct answer? How many of you think the one on the bottom is the correct answer? That's about half and half. This is why we're talking about it, because I need you to get it straight. The bottom one is right. Okay. Now, how can I prove it to you? Well, if I move this to the right 4, and the other one is not moved to the right 4, if I delete this top one, get rid of this one, I clear it, and I just hit graph again. Now, I've only got one thing. Can you read those little tick marks there? Do you see how it's 4 over? I know that's kind of counterintuitive, but remember, the stuff on the inside is kind of counterintuitive. So if you're feeling like, wait a minute, that's backwards from what I was thinking, maybe that's because the stuff on the inside is backwards from what you think. All right, so I'm going to go back to the y equals and show it to you one more time. You want those parentheses in there whenever you're doing stretches. Okay, if you don't have the parenthesis in there, it also is true on flips. If you don't have the parenthesis in there on a flip, if I made this a negative sign instead of a 5, same thing would happen. It wouldn't work right without the parentheses. And some of you goofed that up on the test too, which I'm not surprised since you didn't know right now. Okay, so moral of the story, when you're doing a stretch, you got to remember parentheses on the inside are important. Okay, last thing. Use this little system here to do these 3 things to a parabola. I would like you to get it to move up 2. This is from a parent parabola. I want you to get it to move up 2. I want you to do a up-down flip, otherwise known as a reflection over the x-axis. And the third thing I want you to do is make it 3 times narrower. Actually, that's going to be a hard one to do. I'm going to say 2 times narrower. 2 times narrower. So type that on your calculator, and in a second, I will have you compare yours to like the person in front of you or behind you or whatever I tell you. Make your parabola move up 2. Up, down, flip. And 2 times narrower. From the parent. Okay, there's a normal parabola. Goldberg, tell me one thing that needs to happen. All right. I'm going to go insert 2. Mr. N, front row, tell me what needs to happen. That would make it half as wide. Is that what you want? Well, and the other 2 must not be right then. So you guys tell me, where do you want the 2? Do you want it on the inside or the outside? Ah, the one on the outside would make it what? Twice as tall. All right, so that's not a 2 there. What else does this need? Yes? Negative on the outside. I'm going to insert a negative. That's an up-down flip. Do you guys agree? Okay. And the last one says up 2. Have we done that yet? Plus 2 where? On the outside. Gotta get out of that. Say plus 2. All right. I want you to show your y equal screen to the person sitting next to you. Can be in front or behind you. Just show it to somebody. Got the same thing. Hit graph. Hit graph. See what you get. Does yours look like mine? All right. Now we're going to do a little guided exploration here. I'm going to do this worksheet as your homework. I'm going to do some of it with you. So here it is. You're going to want to stay with me as I do the first few with you. All right. 2, 3, 4. Okay. Do you see how we have a function and it kind of looks like an M? All right. And instead of x and y, we have x and f of x. You get how f of x is pretty much the same thing as y? So when they say x and f of x, it's a lot like saying x and y, right? All right, let's make a list of the points that we have that are important before we connected the dots. Do you agree that we had 0, 0? Okay. Do we have 1, 1 on our graph? Yes, we did. Here's the first hard one. What is it? 2, 0. over 2 up 0. And the next one? 3, 1. And the last one? 4, 0. Okay. If we're going to do 2f of x, should that make it twice as tall or twice as wide? Twice as tall. Think about our m being twice as tall, but the same width. Do you get how it's going to be something like that? All right, now here's how you get the exact points for where it moves. Which one are we changing? Are we changing the x? That's the width. Or are we changing the y? That's the height. The y. So my new point is still got the same x, but the y has changed to, instead of, well, in this case, if I double 0, isn't it still 0? Yep. In this case, this point right here, 1, 1, if I move it up to twice as tall, do you get how that should be there? So it's now 1, 2. 1, 2. Get that? This was 0, 0. What we're doing is taking the original points, which are all right here. There's a point, there's a point, there's a point, there's a point, and there's a point. And we are changing them and making the new points over here. Get what I'm doing here? I think we could have even eliminated this middle column here and just had, okay, the original one is on the left and the new point's on the right. So this next one, the 2, 0, that's going to turn into 2, 0 because I double the y and it's still 0. 3, 1 turns into 3, 2. And the last one is 4, 0. Still 4, 0 because the y of it doubling 0 doesn't change it. All right, so now graph those 5 points on your graph. 0, 0, which we already had. 1, 2, 2, 0, 3, 2, 4, 0. Connect the dots. See how our m got twice as tall? All right. Now let's go over to the right, and that one is 1/2 f of x. Let's just get rid of this middle column again. I don't like that middle column. Scribble that out. What we need is our original points. What we already had the original points. That's easy. 0, 0, 1, 1, 2, 0, 3, 1, and 4, 0. And now I got to make my new points. This one, the 1/2 is still on the outside, so that only affects the y. So my x's are all the same. See how I can copy all these numbers for the x all over here? 2, 3, and 4. And now I only need to change the y's, right? It's only the y's that are going to get half as tall as they used to be. What's half of 0? Stays 0. What's half of 1? 1/2. What's half of 0? 0. What's half of 1? 0.5. What's half of 0? 0. And now, if I graph these points right here on my graph, I'll graph them in green. 0, 0 is still on the list. 1, 1/2, right there. 2, 0. 3, 1/2. 4, 0. Doesn't it make sense? The little thing should be short, but the same width. This originally wasn't an M, and we switched it around to make it a Minnetonka M, as it looked cooler than the original shape. It was kind of boring. Okay, do you get the idea on how that worked? Now let's do the ones on the bottom of the page are the ones where you stretch it the other way. Okay, notice this time actually where's f of x? There's no original place to put the original points on this one, is there? I don't like that. All right, I'm just going to explain this one. I think this is a goof up on the worksheet. I think this should say f of x right there. Yep. All right, everybody, change this right here to be an f of x. This is like on the bottom row. Instead of x and 2x, it's x and f of x. Same thing over there. These are our original points. We need our original points. X comma y. So the original points are again 0, 0, 1, 1, 2, 0, 3, 1, and 4, 0. Okay, now this time we're messing with the y's. Or is it the x's? This should be messing with the x's. Ugh. It's all goofed up at the bottom of the page. So we're just going to skip that. Lucky you. Okay. We're instead going to flip the page to the back side, and I will show you what to do on the back side. Sorry about that. I don't know what happened to that thing. All right. On this, let's see if I can move this thing over a little bit. There. Here's your first problem. Why do you think I wrote those points down there in black? Those are the numbers for that graph. That graph is kind of hard to do freehand. All we did is just copy down what points make up that graph. I would recommend you write them down just like I did. You can put them, maybe you should put them over in this place right here or wherever. Don't care. Write down your 5 points. Negative 5, negative 3, negative 2 comma 3, 2 comma negative 1, 3 comma 3, and 5 comma 4. Now, if I'm going to do this to my graph, I'm not going to make it twice as wide. What's it going to do? Twice as narrow is a way to say it, or you could say half as wide. Since it's on the inside, it's only a wide thing. It's not making it taller at all. It's only affecting the inside, which is left-right stuff. So, my new points, something comma something. You can put them wherever you want. If you already put originals here, you can put them off to the right and maybe over here, whatever. But you need 5 new points to make this graph. And now just think it through. If I'm doing left-right stuff, which number should I change, the x number or the y number? The x number. So let's go take all the y numbers and write them in because we already know them and they're not going to change. You get what I'm doing here? I'm just copying down the y numbers because the y's aren't going to change. Okay, so back to, we've copied down our y's. Their y's didn't change, but what's going to change? The x's. Are the x's going to get twice as tall? No. Stuff on the inside does the opposite of what you'd expect. Half as big, yes. So what is half of negative 5? Negative 2.5. Half of negative 1, or half of negative 2 is negative 1. Half of positive 2 is positive 1. Half of 3 is 1.5, or 1.5. And half of 5, 2.5. And now if I graph these points, it will make my graph. You can try to do this freehand, but I'm telling you, it's really hard to scrunch a squiggly line drawing down freehand. It's much easier to take your points, thank you very much, and rewrite those points. All right, so negative 2.5 and negative 3 would be there. And negative 1, 3 would be there. And 1, negative 1 would be there. And 1.5 comma 3 there. And last is 2.5 comma 4. Now if you connect the dots, it's the same graph we had. I think I goofed something up. What did I? It doesn't look right at the end. 1.5 comma 2 is in the wrong spot? Or, oh, it's supposed to be 1.5 comma 3. Thank you. That's what's wrong. 1.5 comma 3 should be up to there. And then my last point was okay. 2.5 comma 4. There we go. Now it looks more correct. All right. So the whole thing got scrunched down and it's half as wide as it used to be. All right. These are kind of hard. But what it always comes back to is take your original points, then decide if you're going to mess with their x or if you're going to mess with their y. You usually don't do both. And then rewrite the points after you've changed them. So on this one right here, are we going to mess with the x's or the y's? The y's, because it's on the outside. That's up, down. That's y. So I'm going to mess with all my y's. So all my x's are going to stay the same. So I'd write my points down with the x part, leave, because we're going to leave that alone from the original. And 3 and 5. And then I would change all my y numbers. My y's are all going to get twice as big. The stuff on the outside does exactly what you'd expect. Seems twice as big. It is twice as big. So I take the y's and I double them. And my -3 becomes -6. My 3 becomes 6. My -1, I double that, -2. My 3 doubles to 6, and my 4 doubles to 8. You graph those points, you'll see that it has gotten twice as tall as it used to be. All right, so your homework is to finish this worksheet, which is going to be fairly easy because, heck, I did some of it with you already. I did 1/4 of the back side. The front side, you don't have to do any more than what we've already done. And then tomorrow's worksheet's going to be on the long side, so I'm going to give it to you now. You do not have to get on this now. But for those of you that are organized and know that, oh my gosh, my tomorrow's going to be really busy because you have to study for a science test or whatever, you can do the front page of this. You already know how to do this stuff. The only other thing I would say about it is that it's got two things going on at once, like you're stretching it and moving it. And so this is the hardest stuff we've done so far. All right. So anyway, here's the first problem off of tomorrow's worksheet. What do you think is happening on the inside? It's dividing by 2. What's that the same exact thing as? Multiplying by what? Nope. Nope. Let me just ask you this. What could I put right here that would make it the exact same thing? 1/2. Do you get how those two are the same thing? 1/2 x is the same as x over 2. Does that make sense? So this one's a lot easier because you can see, oh, there's a 1/2 on the inside. Never trust what's on the inside. So it's not half as wide. What's it doing? Twice as wide. Okay? So this is your first one on this worksheet that I'm about to hand out. Is I'd rewrite this way, and now you know, oh, just take all the points from the original parent function, which by the way would be square root of x, and you should be able to know what those parent function points are all by yourself. You know, they kind of look like this. Over 4 up 2, over 9 up 3. Remember the square root? And you should be able to say, okay, now I got my parent one, and I'm going to make all of the ones on the inside, the x numbers, change. Okay, if you get stuck, ask me for help.